Right now, 24 billion kilometers away from where you're sitting, there is a human-made object. It's the size of a small car. It's freezing cold, over 270 degrees below zero. It has no GPS, no camera facing forward, and it hasn't had a software update in 47 years. But it's still talking to us. Here's what blows my mind. The signal it sends home, by the time it reaches Earth, it is 22.5 hours old, and it arrives so faint that to detect it, NASA needs one of the largest antennas ever built. And even then, the signal is 20 billion times weaker than a digital watch battery. So the question isn't just, how do we build something that survived this long? The real question is, what did Voyager find out there that we never expected? Voyager didn't just leave. It rewrote everything we thought we knew about our solar system, about space itself, and about what happens when you cross the final border of our cosmic home. And it's carrying something else. Something that has nothing to do with science. Something deeply, strangely human. This is Lazy Wanderers. Come wander with us the mysteries of deep and eternal space. September 5th, 1977, Cape Canaveral. A rocket launches carrying Voyager 1 into the sky. Nobody cheers because they think this will be a short mission, maybe 5 years, a quick tour of Jupiter and Saturn. NASA scientists were wrong by 47 years.
We have ignition. Voyager has cleared the tower.
Here's the genius move that made all of this possible. Gravity assist. Instead of burning fuel to accelerate, Voyager used the gravity of planets, like a slingshot, to gain speed for free. Jupiter gave it a 35,000 kilometers per hour boost. Saturn pushed it even harder. Today, Voyager 1 travels at over 61,000 kilometers per hour. It's the fastest human-made object ever to leave the solar system. After almost 2 years of traveling since the launch, Voyager 1 was now touching distance away from Jupiter. Now, this wasn't the first spacecraft to encounter Jupiter. It was Pioneer 10. It took wonderful images of Jupiter, but didn't quite grab the attention of the common public. But sending back images as stunning as this, Voyager did grab all the attention. Scientists were stunned by these visuals. They made several observations on Jupiter's wind patterns. They saw the great red spot up close, and honestly, it was amazing, all these visuals. But what was more amazing was it found something nobody predicted. Active volcanoes on Io, one of Jupiter's moons. Not dead craters. Live volcanoes, erupting in space. The first time we had ever seen volcanic activity on any world other than Earth. Then at Europa, another moon, it spotted what looked like a cracked, icy surface. Scientists later confirmed, beneath that ice, a liquid ocean, possibly the best candidate for extraterrestrial life in our entire solar system. Voyager gave us our first hint. Talking about stunning visuals, Voyager arrived at Saturn after traveling for 1.5 years. Before the Voyager encounters, scientists believed that the Saturn had only a few broad rings. Voyager 1 revealed that the structures are actually composed of thousands of thin ringlets. The rings, which we thought were simple, turned out to be a living, churning system. Thousands of ringlets, some braided together like rope, some with gaps created by the gravity of tiny moons orbiting within them. After visiting Saturn in 1980, Voyager 1 was not headed toward another planet. Its path was intentionally changed during the Saturn encounter to fly close to Titan, Saturn's largest moon. While doing so, it also bent Voyager 1's trajectory upward out of the plane of the solar system, cross the heliopause, enter interstellar space, and continue sending data about the environment between the stars. In 1981, Carl Sagan made a request when Voyager was already beyond Neptune, 6 billion kilometers away. Sagan asked NASA to turn the camera around. However, NASA did not approve it immediately. After about 8 years and 6 separate requests, NASA finally approves the idea. Just once. Look back.
Flight, we are go for the final portrait. Send the command to turn her around. Use give safe to dawn.
February 14th, 1990, Voyager 1 turns around and takes the famous family portrait of the solar system.
Consider again that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives.
For decades, scientists wondered, where does our solar system actually end? There's no wall, no sign. But there's a boundary, the heliopause, the point where the solar wind, the stream of charged particles from our sun, finally loses its battle against interstellar space and stops. Nobody had ever crossed it. We didn't even know exactly where it was. In August 2012, Voyager 1 crossed it. We know because the instruments detected a sudden change. The plasma around the spacecraft shifted completely. The sun's influence was gone. For the first time in human history, something we built was in interstellar space, outside the solar system, in the void between stars. And it was still calling home. But then, in 2023, something strange happened. Voyager 1 started sending back gibberish, garbled, repeating data, the same pattern over and over. For 5 months, engineers had no idea what was wrong. Remember, this spacecraft is so far away that a single radio command takes 22.5 hours to arrive, and 22.5 hours to receive a reply. Every troubleshooting attempt takes 2 days. Engineers went through old manuals from the 1970s, handwritten notes, printed code from a time before personal computers existed. And in April 2024, they found it, a single corrupted chip in the flight data system. They worked around it, rerouting the data through other parts of the ancient computer. And Voyager 1 came back, still talking, still working. 24 billion kilometers from home.
We have lock. Telemetry is clean.
Remember at the beginning, I said Voyager is carrying something human? Something that has nothing to do with science? Here it is. Strapped to the side of the spacecraft is a golden record, a 12-inch gold-plated copper disc. On it are sounds, rain, wind, a heartbeat, the cry of a baby, waves crashing on a shore, music, from Bach to Chuck Berry to an Indian morning raga. There are 55 greetings in different languages, including a message in ancient Akkadian, a language no human has spoken for 2,000 years. There are photos of a woman eating fruit, a man in a supermarket, children running in a field. And there is one more thing, a message from the then U.S. President Jimmy Carter. It reads, "We cast this message into the cosmos. We are attempting to survive our time, so we may live into yours."
As the Secretary General of the United Nations, an organization of 147 members who all of the humans of the planet Earth, I send greetings on behalf of the people of our planet.
So here's the burning question I promise you an answer to, and it's not a science question. Why did we do this? Why did we send a record full of music and laughter and heartbeats into the darkness, to a place no human will ever reach. Because Voyager was never just a spacecraft. It was the most honest thing humanity ever made. It didn't carry our wars, our borders, our religions, our politics. It carried a heartbeat, a child laughing, rain falling on a Thursday afternoon somewhere on Earth. It was us saying, we were here, we were small, and we were trying. And right now, that record is floating through interstellar space, between the stars, in a silence so deep that even light takes 4 years to cross it. It will outlast every building, every book, every digital file we have ever made. In 40,000 years, Voyager 1 will drift past a star called AC plus 793888. Nobody alive today will be there to see it. No human ever will. But if anything, anywhere, ever finds it, they will hear us. They will hear a heartbeat. Voyager 1 has enough power to keep transmitting until around 2025 or 2026. After that, silence. Its nuclear batteries will die. Its signal will disappear. And it will drift, dark and quiet, for billions of years, the farthest traveled human object in existence. A fossil of everything we were. But here's the thing that gets me. Even after the signal dies, the golden record doesn't. It's rated to last 1 billion years in the cold of space. We might go extinct. Our sun might explode. The Earth might be gone. And that record will still be out there, drifting, waiting. The universe might forget us. But we made sure it'll at least have the chance to remember. Thanks for wandering with us. NASA also launched another Voyager called Voyager 2. What happened to that? Where is it now? Well, that's another video.